Data sets might be records. Data sets might be graph and network. It can be ordered data, for example, with video data, temporal data, sequence data, or genetic sequence data. It can be spatial data, image data, multimedia data. So these are all the types of data. Okay, this is a document wherein we are counting how many words are there, how many times one word is has occurred in the document, and this is a transaction record, that is transaction ID and items they are purchased. So these types of all records, so these are the data sets. Now, what are the important characteristics of structured data? First characteristic is the dimensionality. What is the dimensionality? Dimensionality, in very simple words, dimension means columns. If you assume a data as a row and column, then dimension means column. For example, employee data, in the employee data, employee name, employee salary, employee designation, these are columns. They are called dimensionality. Then sparsity. Sparsity means what is the count of the data. Then resolution, patterns depend on the scale. Data distribution, centrality and dispersion of data. So these are the important characteristics of the structured data. Now, data objects, as we have seen yesterday, data sets are made up of data objects. So data objects represent an entity. For example, sales database, customers, store items, sales are the entities. In a medical database, patients, treatments. So in the DBMS language, entity means a table itself. So suppose customer table, patient table, student table. So entity means a table. So it is a data object. Now, they are also called as instances, data points, objects, or tuples. Data objects are described by its attributes. Now, what are attributes? Database rows are called as attributes. So, if we consider a database, its rows are the attributes of a database. Now, attribute, we have seen types of the attributes, that is nominal, binary, numeric, okay, and ordinal. So, for example, customer ID, name, address are the dimensions, features, or variables. That is the attributes of any employee uh, object, suppose. Then customer ID will be of nominal type, name can be of nominal type, address can be of nominal type, then gender can be of we can say as a binary type, and then salary can be of numeric type. So these are the types of attributes. So we have seen this nominal, binary, ordinal attribute. Binary is again symmetric and asymmetric. Symmetric means both outcomes are equally important, and asymmetric means outcomes are not equally important. Ordinal means there is a meaningful order in the data. This is called ordinal attribute. Numeric, there are two types, interval scaled data and ratio scaled data. So interval scaled means there is an interval between two data two data points, and ratio means there is a ratio. For example, 1 has to 2, 2 has to 4, like this ratio in the two data points. Discrete various versus continuous data attributes. Discrete attributes are those who are finite or countably infinite set of attributes. For example, integer variables. All integer variables are discrete attributes. Those which are not discrete are continuous. For example, here float variables or real values we can say them as a continuous attribute. So up to here we have seen it yesterday. So today we are going to start with basic statistical description of data. So why do we need to describe the data statistically before proceeding to the data mining? So the motivation behind this is to better understand the data. So to better understand the data, what we should know is the central tendency of the data variation, and the spread. Now, how do we measure the central tendency of the data? Central tendency is measured by mean, median, and mode of the data. Variation can be measured by your variation analysis, and spread can be measured. So there are various techniques. So data dispersion characteristics. So data dispersion can be measured as median, max, mean, quantiles, outliers, etc., etc. So let us see this measuring the central tendency of the data. Now, what is the central tendency? Measuring the central tendency. Central tendency of any database is measured with the help of mean, median, mode, and mid-range of the data. Now, what is mean? Mean is a algebraic measure, that is, uh, suppose for example, uh, let us take here, no examples, okay. Let's take finding mean. The most common and effective numeric measure of the center of set of data is the arithmetic mean. For example, let us x1, x2 up to xn be a set of n values or observations, such as for some numeric attribute x, like salary. The mean of this set of values is x bar, that is mean is equal to summation of I is equal to 1 to n, means number of data sets xi, that is all data divided by n, so which is equal to x1 plus x2 divided by n. So this corresponds to the built-in aggregate function average in the SQL, is provided in relational database system. So mean is nothing but the average, which is calculated by addition of all the data points divided by the number of data points. So this is called as mean. Now, for example, suppose we have the following values of salary in thousands of dollars. Okay, shown in the increasing order. So this is the increasing order of the salary. For example, 30, 36, 47 up to 110. So this is the salary range. Okay, so starting salary, it is ordered in a increasing order, right? So how to calculate the mean of this data is x bar is equal to add all these salaries and divide it by 12, because these are 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11 and 12. So these are 12 data sets. So here we get 58,000. So mean of this is a $58,000 is the mean of this data set. So next one is finding the median. What is a median? For skewed, that is asymmetric data, a better measure of the center of data is the median, which is the middle value in a set of ordered data set. It is the value that separates the higher half of a data set from the lower half. In probability and statistics, the median generally applies to numeric data. However, we may extend the concept to ordinal data also. Suppose that a given data set of n values for an attribute x is sorted in increasing order. If n is odd, then the median is the middlemost value of the order set. If n is even, then the median is not unique. It is the two middlemost values and any value in between. If x is a numeric attribute, in this case, by convention, the median is taken as the average of the two middlemost values. For example, let us take the example which we have taken for the mean. The data is already sorted in increasing order. So there is even number of observation, that is 12. Therefore, the median is not unique. It can be any value within the two middlemost values, that is 52 and 56. So if we see this data set, if we consider this data set 12, so there is no middlemost value. So what we can do is two middle values we will take, okay, and 52 and 56, okay. 52, that is the fifth value and the sixth value. So we will take it and we will find the median, that is add them and find the average of them. So by convention, we assign the average of two middlemost values as the median, that is 52 plus 56 divided by 2, which is equal to 108 divided by 2, which is 54. Thus median is 54,000. So given a data set, a median is the middlemost value if the number is odd. If it is even number, then the two values Average of the two middlemost values is called as the median, right? Now, what is mode? The mode is the another measure of central tendency. The mode for a set of data is the value that occurs most frequently in the set. Therefore, it can be determined for a quantitative and qualitative attributes. It is possible for the greatest frequency to correspond to several different values, which results in more than one mode. Now, what is mode actually? The mode is most frequently occurred value. So how many times the value is occurred in the data set. So the value which has occurred mostly, the maximum time in the data set is called as a mode of that data set. So a data set can have one, two or many values which occurred many times. Okay. So they are respectively called as unimodal. That means if a data set has only one value which has occurred many times, then it is a unimode data set. For example, if we consider age as a data set, then if there are, if the uh, average, not average, if 25 is the age which has occurred many a times, then it is called unimodal data set. Bimodal means two values have occurred many a times in a data set. Trimodals means three values have occurred many a times in a data set. In general, a data set with two or more modes is also called multimodal. At the other extreme, if each data value occurs only one, then there is no mode. So every value is occurred only one time. So there will be no mode in the data set. For example, the data set which we have taken is a bimodal because the two modes are 52,000 and 70,000. If we look at this data set, so here 30, 36, 47, 50, 50 to 52 has occurred two times and then again 70, 70 has occurred two times. So it's a bimodal data set because two values have occurred two times. So this is a bimodal data set. For unimodal numeric data that are moderately skewed, that is asymmetrical, we have the following formula, that is mean minus mode is equal to 3 into mean minus median. Okay. So in general, what is a mode is the value which has occurred most of the times in the data set. Now, what is mid-range? The mid-range can also be used to assess the central tendency of the numeric data set. It is the average of the largest and smallest values in the set. So, what is mid-range? Actually, mid-range is the average of the largest and smallest value in the set. This measure is easy to compute using SQL aggregate function, that is max and min. So if we consider our data set, the mid-range of the data example which we have seen is the minimum value is $30,000, maximum value is the $110 divided by 2, which is equal to 70,000. So mid-range of this given data is 70,000. So many a times a question is asked, calculate the mean, median, mode and mid-range of the given data set. So these are the formulas to calculate it. It's very easy. So mean, median and mode of symmetric versus positively and negatively skewed data. Now, have you understood? I think you must have understood the mean, median, mode and mid-range of the data. Okay. So let us next find out what is the mean, median and mode of symmetric versus positively and negatively skewed data. So look at this graph. If you look at this graph is plotted for the points of the data. For example, if we consider this our data set, the graph is plotted of this. Okay, so graph of which points have been plotted here in a unimodal frequency curve with perfect symmetric data distribution, the mean, median, mode are all at the same center value that is shown in the 2.1. So this is a symmetric data. Symmetric data means what? All the mean, median, mode are at the same value. That is, for mean, median and mode, there is only one value. Okay, so the data is called symmetric data. For example, if we consider 10 times, this is a symmetric data. So mean will be 10, median will be 10, mode will be 10, like this. Okay, so this is a symmetric data. What is positively skewed data? Positively skewed data. Data in most real applications are not symmetric. They may instead be either positively skewed, where the mode occurs at the value that is smaller than the median. That is, the mode occurs at the value which is smaller than the median, which is called positively skewed data, whereas negatively skewed data is where the mode occurs at a value greater than the median. So here the mode is occurred at the value which is greater than the median. So here three bars are shown. First one is mode, then there is a median, and then there is a mean. This is called positively skewed. If we look at this graph, this is going upward and then going downward. So it is positively skewed. Now, what is negatively skewed? Initially, it is less, then it is going up and down. So, this is mode. So, mode comes after the median, that is negatively skewed data. Okay, so symmetric versus, so this same diagram has shown over here mean, median, and mode of symmetric, positively and negatively skewed data. So, this is symmetric, this is positively skewed, and this is negatively skewed. Now the second thing is measuring the dispersion of the data. So basic statistical description of data. First of all, we have seen what we have seen first of all. So here, if we go here, basic statistical description of data. Here, so measuring the central tendency. So we are done with measuring the central tendency. Now what we are going to do is measuring the data dispersion. So central tendency अब हो गई है. Now we are moving towards data dispersion. Now what is data dispersion? Is range, max, mean, quantiles, etc., etc. So finding all this is the. So let us look at this. Measuring the dispersion of data. How dispersion of data is measured? With the help of quartiles, outliers, and box plots. Now here we have to see all these terms: quartiles, interquartile range, 5-number summary, box plot, and then outlier. These are quartiles, outliers, and box plots. Then we are going to see variance and standard deviation of the given data. So firstly, we will see what are quartiles, interquartile range, 5-number summary, box plot, and outliers. So first of all, we will see what is range, quartiles, and interquartile range. So let's x1, x2 up to xn be the set of observation for some numeric attribute x. The range of a set is the difference between the largest and the smallest. So what is the range of any data set? Is the difference between the maximum and the minimum. This is called the range of the data. For example, I am considering the salary data, then the minimum is 30, maximum is 110. So the difference between both these two is called the range of the data. Now what is quantile? Quantile points are taken at regular intervals of a data distribution, dividing it into essentially equal size consecutive sets. Okay, so you must be knowing 100 quantiles. 100 quantiles means most commonly referred to as percentiles. They divide the data distribution into 100 equal sized consecutive sets. So normally, what is quartile? Quartile means the data is divided into 4 quarters. You know quarters. So 4 quarters. So first quarter, second quarter, third quarter, and the fourth quarter. Each quarter is known as a quantile. Okay. Let us see this example over here. So if this is my data, then this is my Q1. This is a quantile. So first quantile. Okay. Which is a 25% of my data. So I have divided the data into four same equal distribution set. What is quartile 2? That is quantile 2 is a median always. That is the 50% of the data. Third quartile is the 75th percent of the data. And the fourth one is the last is the 100. That is 100%. So this is called quartiles. Okay. So Q1, Q2 and Q3. These are the three important uh, quantiles over here. Q1 is the 25th percentile. Q2 is always a median, which is a 50 percentile, and Q3 is the 75th percentile. Okay, so this is a graph which is the three quartiles divide the distribution into four equal size consecutive subset. The second quartile corresponds to the median. So these three quartiles have divided the data into three equal sized parts. Now, the quartiles give an indication of a distribution center, spread, and the shape. The first quartile, denoted by Q1, is the 25th percentile. It cuts off the lowest 25% of the data. The third quartile, denoted by Q3, is the 75th percentile. It cuts off the lowest 75% or highest 25% of the data. The second quartile is the 50th percentile. As the median, it gives the center of the data distribution. Okay, so understood. If we consider this example, which we have seen, if we there are 12 let us consider this example. How many values were here? So there were 12 values. So if we divide this data into four equal sets, then 50 will be the first quartile, 60 will be the, sorry, 47 will be the first quartile, 52 will be the 52 will be the second quartile, 63 will be the third quartile, and 110 will be the fourth quartile. Like this, we can divide this into equal sized data. So these are called as quartiles. So if we consider this data set, then we will divide it into 3 equal parts. So third part, that is 47, will be Q1. Here 52 will be Q2. 63 will be Q3. And 110 will be the last. Okay. So like this, they are the Q1, Q2 and Q3. That is quartiles of the given data set. Right? Okay. What is now? What is next is a interquartile range. What is a interquartile range? Let's see this interquartile range. So the distance between the first and third quartiles is a simple measure of a spread. So that gives the range covered by the middle half of the data. This distance is called the interquartile range, and it is defined as IQR is equal to Q3 minus Q1. So suppose we take this diagram, we consider this diagram. This Q3 minus Q1 is the interquartile range, that is IQR of the given data set. If we consider our example, then what is our Q3 point minus, if we deduct, if we do the minus subtraction, Q3 minus Q1, we will get the interquartile range of our data set. Okay, so interquartile range, the quartiles are the three values that split the sorted data set into four equal parts. The data of example contain 12 observations already sorted in increasing order. Thus, the quartiles for this data are the third, sixth and the ninth values respectively in the sorted list. Therefore, Q1 Q1 quartile is 47,000 and Q3 quartile is the 63,000. Thus, the interquartile range is IQR is equal to 63 minus 47. So, it gives us 16,000. So, note that the sixth value is a median, that is the 52,000. Although this data set has two medians, since the number of data set values are even. Okay, so normally the median is the what you can say second quartile, but here we don't have a median. It's a even data set. So 52,000 is a median of our data set. So 16,000 is the interquartile range. Okay, so what we have seen up till now is range, quartiles and interquartile range. What is a range? Range is the difference between the minimum value and the maximum value. Quartiles is dividing the data set into equal four parts. So the 25th percent is the first quartile, 50% is the second quartile, 75% is the third quartile. Okay, so these are the quartiles. And what is interquartile range? Interquartile range is the difference between the third quartile and the first quartile. So this is range, quartile and interquartile range. Now next is, what is next is a box plot analysis. So this is a diagram which is showing you the box plot of a data distribution. So what is a box plot? Box plot is a 5-number summary of a distribution. What are these 5 numbers? 5 numbers are minimum, that is the minimum value, quartile 1, median, quartile 3 and the maximum value. So suppose we take, if suppose we consider this diagram, then what are the points that will be considered in a box plot? This is a minimum value first, then the Q1, Q2, Q3 and the last one, that is the maximum value. So here, to draw a box plot, we need 5-number summary. What is this 5-number summary? Is the minimum value, first quartile, second quartile, that is the median, Q3 and maximum value. Okay, so this is a this diagram shows you the box plot of the suppose this is 0, 10, 20, 100 so given data set. So this is the lower extreme. Suppose 20 is the lower extreme, 100 is the higher upper extreme. This is the box. Okay. So what is this box? This box is a interquartile range. That is, the box lower quartile is here. The box start with Q1 and the box ends with the Q3. So here, if you consider this line is a Q1, this line is Q3, and this is the median of the data. So this is called as a box plot. So this is, first of all, the box plot starts with the minimum, then a line will be drawn, then one box will appear. This box will be IPR, that is IQR, that is interquartile range. That is the difference between the quartile 3 and the quartile 1, that is the lower quartile and upper quartile. This is the median of the data and the upper extreme of the data. If we consider our data set of a salary, we can have, what is the lower number? Lower number is I think 30, upper number is I think 110. We have calculated Q1, Q3 and median. So we can draw the box plot of the given data set. So box plot data is represented with a box. So data is represented with a box. The end of the box are at the first and the third quartiles. So the end of the box are the first and the third quartile. The height of the box is IQR. So this is the interquartile range, difference between the two quartiles. Okay. Then the median is marked by a line within the box. So within the box, the median is marked with the line. Whiskers. two lines outside the box extended to the minimum and maximum. These are called whiskers, which are extended to the minimum and the maximum. Outliers. Now, what are outliers? Points beyond a specified outlier threshold is called a outlier. For example, if we consider this box plot, this is the minimum value, this is the maximum value, and this is the interquartile range. This value appears beyond the box plot. So this is called a outlier. Okay, so these are the outliers. Box plots are used to find the outliers also. Okay, so if we find the minimum and maximum value, then we can find the outliers also. Okay, so visualization of data dispersion, it's a 3D box plot. So if we see this, every diagram here, every point here is a box plot. तो अगर आप देख सकते हैं यहाँ पे, so this is a box plot. It's shown in a, this is a revenue and this is cost and profit. So this side it is given a profit, this side revenue, this side cost. Okay, and the box plots are drawn. So there are various visual applications which are used to draw the box plots of the given data. So this is one of the diagrams shown over here. These all are the box plots for the various ranges of the data. Okay. Now, what are the, okay. So now next is graphic displays of a statistical descriptions of data. Now what are graphic displays? Graphic displays includes box plot, histogram, quantile plot, and scatter plot. That we are going to see in the next lecture. We are going to stop it now. Okay. Do not leave the lecture. Please stay connected.